However, it is not the subject itself. That is a specialized thing, and all of you, I'm sure, will benefit a lot out of it. But what I'm happy about is that the Tech Pioneers is doing good work, that it is keeping you abreast with all the developments in the area of computer science, and that computer science department is progressing the way it should. In the last 6 years, Aribhat College, a new college on the horizon of Delhi University, has made its own impact at various places. I have tried to, project itself as a college in a very short time, as a college that is academically accomplished and which gives out substantive results everywhere. And in that trajectory, the computer science department is also beginning to hold its own place, add to positively to that. Now, that is something that gives a lot of satisfaction to everyone in the college. And my congratulations to all the teachers, fellow faculty members from the computer science department, especially the current TIC, Dr. Preeti Jagwani, who's been doing immense work related to this, and all the others, faculty members also. But special congratulations to all the students who get involved here. Thank you so much. You may be our alumni, student of ours, but when you all come here and contribute in some positive way to the college, it does help the college. And do continue to make your alumni association strong. I hope that the computer science department is by now forming an alumni association of its own and also joining it with the college alumni. And that is something we need to strengthen, and we will strengthen in the near future, and therefore continue to do that. All my best wishes for this workshop and all the activities that you do throughout this session. All the best. Thank you. Thank you for calling me.
Thank you so much.
It was an honor hearing from you, sir, and we hope to have your guidance throughout our journey. Now, I'd like to call Dr. Preeti Jagwani to introduce our mentor for this workshop, Yadullah Abdi. Ma'am, please.
Yeah. Hello, everyone. Our resource person for today is Yadullah Abidi, our current third year student of B.Sc Honors Computer Science. So previously in two episodes of Alumni, I was having the honor of introducing, or I was having the honor of attending the workshop given by our own students. Now here is again one another moment of happiness or for proud for us as teachers, because today's resource person is our current student. Yadullah is an avid programmer, developer with his skill set extending beyond the monitor into electronics, IoT, web app development, and photography or filmmaking. He also contributes content for a major tech publication which is candid.technology. You can check out his articles at candid.technology/author/Yadullah. Yadullah has done internships at prestigious organizations like Google, Makersbox, HCL, TCS, Things Go Social, and ED Times. He was also a resource person for a technical workshop at IISc Bangalore. When in school, Yadullah also wrote a research paper on Windows Mark III. So here I go. I welcome you, Yadullah, for this workshop and looking for a fruitful workshop from your side.
Thank you very much, ma'am, for the really kind introduction. So, I believe ma'am has already said everything that there was about me. So we'll just cut straight to the presentation. Augmented reality is something that has steadily been picking up pace. You all have seen it in terms of apps and other things. Snapchat is the most prominent example that comes to mind. Other apps like Pokemon Go and stuff. So we'll start off with a small theory session on what is augmented reality, how it's different from other similar technologies, and then we'll get on to what we're going to do today. So let me just present my screen. Okay, is my screen visible to everyone? Can I have some feedback in the text chat?
Yes, yes, yes. Screen is visible.
Okay, great. So, augmented reality is essentially a combination of real scene reviewed by a user and a virtual scene that a computer generates. That is the most basic understanding of an AR scene per se. So everything that you see in AR, every single object or every other instance that you see, it can be a 3D model, or it can be an image, or it can be a video. All of those consist of these scenes which are superimposed upon one another. So there's another buzzword going around when we talk about realities. So that's virtual reality. There's a lot of differences between the two. So, for example, augmented reality would augment a real world scene and superimpose it onto a virtual scene, while virtual reality is a completely, totally immersive environment where you're cut off from the real world. You also maintain a sense of presence in the real world when you're augmenting things onto it, because of course you need to be able to interact with whatever's going on around you, while under virtual reality systems your senses are completely under the control of a particular system that the user or the developer wants you to see. Now, augmented reality requires a mechanism to combine both the worlds, while virtual reality needs a mechanism to feed the virtual world to a user. And this is a really important point, as this is where a lot of differences between the two technologies come. Virtual reality has come quite a long distance from where it used to be, but it's still very inaccessible because the mechanisms that are needed, the equipment, the hardware that you need to buy to be able to access it is actually quite expensive, while you can make AR apps on your smartphone and just go around with it. Once again, a last point is it's really hard to register real and virtual objects in augmented reality, and that is the developer's goal, is that you can't tell what is augmented onto the real world, while the VR world is totally immersive. It's a separate world of its own. So it sometimes becomes a little bit harder to, push a world and make it interesting. You need to have really good graphics, and you really need to have that powerful a machine to be able to run those systems and so on. So there's a small theory, and I'm sorry if it gets a little bit boring here, but since we're going to work on AR, it needs to be discussed. So there's this scientist called Milgram, and who coined the term augmented virtuality, which is supposed to be a mixture of AR and VR. That's what we call MR, or mixed reality. If you've seen the Microsoft HoloLens, which is a mixed reality headset. The point of this concept is to identify systems which are mostly synthetic with some real world imagery added. So assume you're in a VR world, but what you see is real. Or assume you're in an augmented world and what you're seeing is virtual, which is the other side of the spectrum on which we will be working today. So what do we need to create AR stuff? We need precise models. We need to know what exactly are we going to project on our locations and optical properties of the viewer, or in layman terms, a camera and a display, which we have in our phones and our laptops. You need all the devices to be calibrated. So your system needs to know what are the measurements of the room or of the hardware or peripherals or tables around it, and to combine all local coordinate systems centered on the devices and objects in the scene in a global coordinate system. So I'm sure all of you must be aware of how 3D objects are mapped in the world. So there are three planes. There's an X plane, there's a Y plane, and there's a Z plane. Now, when you're mapping 2D objects, you're primarily working in a 2D space. You're just working with X and Y. In 3D, we work with X, Y, Z. So that is length, breadth, and height. When you're combining these two worlds, and when you're talking about augmenting something virtual onto something that is real, you have two different coordinate systems. You have the dimensions of the object that you want to augment, and you have the coordinates of the real world around you. So you need to have a global coordinate system, as we'll see in Unity in a little bit, that can combine all of these local coordinates and give you a global system, so that you can properly scale and align your objects. Another thing that two most of that we need to know is to register models of all 3D objects of interest with their counterparts in the scene. So as you can see in the image below, the green ball here is the one that's being augmented, and this is the scene that it's being augmented on. So your software or the device that you're running the AR thing on needs to be able to register the 3D objects, and the point of interest is called the call it a QR code, call it an image on which you augment things. So for example, in this image, this shape of the cardboard will form the point of interest, and this ball will be your augmented model. You also need to be able to track the objects over time, because obviously a lot of you, I'm sure all of you use Snapchat, and every time you move your head around when using a filter, you notice that the filter moves around with you. So that is when the filter that's being augmented on you is also being tracked to your face as you move around. So that's another very important aspect of making an AR app. So realistic merging would require objects to behave in physically plausible manners when manipulated, occlusion, collision detection, and shadows. So this is a little bit of an advanced thing. That's not something really we're diving in on this workshop, but just to give you a touch of it, objects need to behave in physically plausible manners, which means most of these objects need to have some sort of physics working on them. For example, when you play a game and you shoot something, it breaks. It just doesn't stay there like a box, right? So any objects that we're augmenting onto the scene need to have these physically plausible manners or these habits, so that when they're interacted with or when you manipulate them, they behave in a way that they would behave in real life. There's occlusion. Occlusion is a term used a lot in gaming. It stands for how an object behaves when under light. So what reflections it gives out, what shadows it casts, how it looks, basically. Collision detection, of course, when you collide your object with something, depending upon the physical properties of your object or whatever it is that you're augmenting, if it doesn't have any physical weight, then the collision detection would be just simply nothing. If it has a lot of weight and you're using a lot of velocity to move it around in the augmented world, then it's going to be a different type of collision. And then the shadows that it's going to cast, something which this one is what we're going to see in today's thing. So just before I wrap this presentation off and we get into Unity, a few research activities that have been out there for AR. There have been methods that have been developed to register the two distinct sets, the real and virtual. This is more of a scientific thing, but every time we're talking about AR, we divide it into two sets, just like you have number sets and things like that. So you divide it into a real set and a virtual set. So we, yeah. So develop methods to register the two distinct sets, real and virtual, of images and keep them registered in real time. So this often reduces to finding the position of a camera related to some fiducial markers. What this essentially means is that you need to be able to have a key point or a particular rotationary point around which you can reduce your finding point. So if you, for example, post a camera, and you'll notice this as you walk along with me today, that sometimes your augment marker, the marker that you're using to augment 3D sets or whatever onto the real world, sometimes that doesn't quite get detected. Sometimes you use, once again, I'm giving you an example of Snapchat. Sometimes you use Snapchat and it doesn't quite detect your face. So again, using methods to register the two worlds together and keeping them registered in real time, keeping them linked in real time, reduces that latency or that gap in between finding a marker and working along with it. And then, of course, developing new display technologies for merging the two images. If you don't have a good display, AR or VR or MR, any of these three experiences become quite less immersive, you can say. They seem real. Does anybody have any doubts, any questions until this point in time? You can type them out in chat. You can.
I think Yadullah, it is pretty clear till I mean, this point. You can go
Till
ahead for.
point. Okay. Another very important thing before making an AR app or software is performance. Since you're rendering 3D 3D virtual objects into a real world scenario, you're essentially taking what you would need in VR, which is already a very performance intensive thing, and you would be putting it onto a real world. And as long as it's performing smoothly, that's what makes it real. So you need to have a really good update rate for generating the augmenting image, and the accuracy of registration of the real and the virtual image is really important. If you make a really good AR app and it doesn't quite accurately register where you have to put your place marker in the real world, it's basically useless. So we use a term called Brooks paper, which registers things in latency. So 1 ms of 1 millisecond of latency would mean that there is a 1 millimeter displacement of the object in the real world as compared to where you placed it in the software. Two very important things to keep in mind. So every time you make an AR app, you have to think about optimization and accuracy. Now, again, failures in registration. Why doesn't it register when you're trying to augment something in front of a marker? The major reason here is noise. So position and pose of the camera with respect to the real scene. As you'll see by the end of this day one, that the way you angle your camera to what the augment marker is, it really depends. It should be not always in an ideal state, because then that would make the region of interest of your app very small, but it should be a big enough state. Now, if you're really using a very narrow angle, or if you have a lot of noise in between, or the camera quality is way too bad, you will fail to register the augment marker. Then there can be image distortions. If your augmented marker itself is distorted or damaged in any way, shape, or form, you may or you may not be able to register an image. And then time delays in calculating the camera position. This is something that phone apps suffer the most with, because the processor or the internals aren't as powerful. There's a little bit of a delay before seeing the image and registering it, and it often goes down as a failure in registration. Now, display technologies, as I've told you before, we've got laptops, we've got cell phones, projectors. There have been AR projectors as well, but they're not quite there yet. You can say they're mostly gimmicks at this point in time. And then we have head-mounted displays, like I said, the Microsoft HoloLens, which is a video see-through and an optical see-through lens at the same time. Now, how does monitor-based augmented reality work, which is what we're going to do today? So again, this is the simplest available type of augmented reality that people can, access or develop at this point in time. So you basically use your phone or your laptop or display device as a window through which you can see the AR world. So here, as you can see, I have the real world object and my camera is positioned at it. Now, this camera has two feeds going out of it. One is a video of the real scene, and one is the graphic system that the camera is running, which is augmenting the objects. These interact with the video merging software, which we are going to make, and then that final feed is sent to the monitor, or in this case, our phones, or wherever you want to run this app on. Again, monitor-based AR has been successfully commercialized in a lot of places. So VAR, if any of you follow football, we use these augmented reality cameras to figure out whether there's been a goal or not. It's been used a lot of times in hockey pucks, so sports, a lot of application in sports to figure out where the players are, where the ball is. Times Square billboards have been replaced with the AR ads. You can just make an app of your own. You can use a billboard as a marker for that app, and then you can just have your own ads running in Times Square with basically no expenses to it. Baseball cards, again, another sports-based application, and ad campaigns. This is where monitor-based AR has been very successfully commercialized so far. Again, just a small example of optical see-through HMDs. head-mounted displays. HMD stands for head-mounted displays. This is what I was talking about with Microsoft HoloLens. So that is how it works. Since when you're using a phone, you're essentially looking through it. But what happens when you're wearing a display on your eyes? You the same thing, more or less, except the screen is replaced by mirrors, and your head tracker is the one software box with sensors, with gyroscopes and accelerometers that tracks your head movement and can tell where or not this whole movement is going, so to track both the sets and keep them together. Video see-through HMDs work pretty much the same way, except there is no mirror, there's a screen, there is everything that you would expect it to go. So there's a video camera, the real world feed goes in, it sends it down to the compositor, which is a small computer inside it. Then there's your head tracker, which tracks your head location, sends it to the scene generator, which augments the graphic image on it. And then you get the combined video feed into the monitor, which you have in front of your eyes. What are the advantages of having a video see-through HMD, you might ask, against a mirror one, which is obviously cheaper to make and has less complicated technology? Well, the biggest the biggest advantage of such a headset would be flexibility in composition strategies, to be really honest, and that is the one big advantage, because real and virtual view delays can be matched. You can still do that with a mirror see-through HMD, because if you have a computer strong enough, it can process all of the things that you throw at it. But being able to change your composition strategy, being able to change where you want to place objects as and when you go along, is a really big advantage as you learn if you stick to AR development. Again, optical see-through HMDs are simple, offer better resolution because you're seeing the real world, and there is no eye offset needed, because again, you're just seeing light reflected off mirrors go into your eyes. Though you don't need to adjust the monitor to be able to work close at that closer range with your eyes properly. Now, advantage of monitor displays, which is something we are working on. So these are consumer level equipment, your laptops, your phones. These are the most practicals, and a lot of the research is currently aimed here. A lot of products have been developed for this already. You will realize just how easy it is to make one, and this is why you should really pursue monitor display AR if you're into it. And the other current active area is a flip down optical display, which is basically your screen being reflected on a sheet of glass. So if you've seen Iron Man, if you've seen Tony Stark's lab and all of the things that he does in the air, so all of his panels are hanging, that is basically this. So yeah, it is possible to make that if you can stick together the composition for it. Now, these are just a few of the early applications of AR, and these have come way before than you might think. So Karma was a finer machine designed in 1991 for diagnosing medical conditions. There have been optical see-through HMDs. There have been knowledge-based assistants for maintenance. So they can augment things onto something you're trying to repair, and you know what to do along. There are ultrasound trackers that help in assembling very precise machinery. There have been tour guides and movies and things like that. There is ECRC, which is sort of a mechanical application of AR, where you basically take an engine and you augment parts on it to see what will work, what wouldn't, how will it go, how you make an engine, what parts fit best, and things like that. Again, medical, a lot of early 90s research here. So basically, what the medical field did for AR was to reduce a lot of registration errors, because obviously if you register something incorrectly and you're performing a medical surgery, you can be in big trouble. Because otherwise, if let's say you're operating on a heart and you operate the heart 2 centimeters and you register the heart 2 centimeters lower than where it is, it might not be a problem when you're doing this in a fun app, but in a surgery that can really make a difference. Again, it's an MRI, which is doing the same thing. It's augmenting the patient's brain, hypothalamus specifically speaking, onto their head as a LED screen above the patient. And then, of course, there have been instructional courses and things like that. So there's been a movie called Magic Book, which provides a natural interface for kids to learn. There have been games. You all have heard about Pokemon Go. AR Quake is another very popular AR game that's basically a AR representation of Quake itself. And that's about it. So how many of, okay, before we continue, does anybody of you have any doubts so far? You can type it out in the chat if you want to ask anything in terms of the theory part. Okay, great. Then let's move on. Before we start working in Unity, I would want to know that how many of you have the software actually installed on your systems and running. Can I have a show of hand, some feedback in the chat, please, about the software? Because if you don't have Unity installed and you're just seeing here, you're not really going to pick a lot up from it. Guys, I need a response. Okay, I've got one. What about the others? Okay, two. There are 45 people. I need more people to be installed Unity so that we can proceed. Okay, never mind. Let's move on then. So I am now presenting my entire screen for you all to see. Can you see my display yet? Installed but not working. Okay, Mohit, you can type out your issue in the chat box. I'll see if we can resolve it really quickly. In the meantime, let's go ahead and open Unity Hub. So is this the screen you all have on you right now? Yeah, I'll help you figure that out just right away. So this is the Unity version that we'll be using. But before we get started, we need to finalize our license. And then we'll get back to installation problems again. So just click on this settings icon here and just click on license management. I already have a personal license activated, but you're going to have to activate a license for yourself if you're just starting to use Unity. So just click on this manual activation button and it will ask you to save a license request. Click on it, it will save a file, just save the file somewhere on the desktop or something. And then there is this link. Now we need to go to this link and install this application file. So can you see my browser?
Yes, yes.
Okay. So just wait for it to load and click browse, find the file that we just saved, which is this. Click open, next. It will ask you to activate your license. Just use the personal edition because we're not using it in a commercial or a professional capacity. Just select this and click on next, and then it will give you a license file to download. Now, just download this license file. I'm not going to download it because I already have one activated. So click next here, and now the license file that you've downloaded, just load it using this box and wherever you've saved it, and click on confirm. That should resolve all of your license issues. Is everybody with me yet? Okay. Cool. Has anybody left behind? Should I continue? Okay, so let's continue then. Now, come to the projects tab and just click on new project. So we're going to start with a 3D project. Name it whatever you want. So I'm just going to name it Arabata AR workshop, and you can save it wherever you want. Now there are a lot of different things here that you can make. You can make VR things. There is a inbuilt AR thing, inbuilt AR support for Unity, but we're not going to use that because it's a little bit more complicated than what we're doing today. You can make Lego micro games if you want. There is a karting micro game template. These are all basically templates for you to play around and see. So we'll just continue with 3D, type in a project name and click on create. And now just wait for Unity to launch. Okay, so now that we have Unity launched, the first thing that we're going to do is install the Vuforia plugin. So Vuforia is an external SDK that facilitates AR development for just about anything. It can be an app, it can be Android, iOS, or a desktop app, or a Linux kernel development procedure. It could be basically every avenue that you want to cover across all platforms using just one standardized library, so you don't have to rewrite your code, or you don't even have to code at all for this one. So let's just go to Window, go to Package Manager, and let it load up. You will see a small search bar here. Just click on it, wait for it to load up, and search for VUF, Vuforia. Yeah. So Vuforia Engine AR, make sure that this is installed. So we're going to click install here, and it'll just take 5 minutes to download and reinitialize all of these files. Are you guys following? On what step are you guys? Can I have some feedback in the chat, please? Okay. Mohit, were you able to resolve your license issue yet? Are you continuing with this? Okay, installing Vuforia. All right, so now that Vuforia is installed, we can just close this window and move on. Now we've got a little bit of setting up to do. So the first thing that we're going to do is deleting this main camera. Still showing invalid license. Okay, you need to give me a little bit more information on that issue. I can't really work with that information. Okay. Or we'll just get back to you at the end. I'll try and wrap this up rather quickly so that we have time for questions. Okay. Yep. So is everybody at this screen right now? Can I have some feedback in the chat? Okay. All right. Let's continue then. Now, since for today we're only developing on our PC, I'm not going to change the build platform, because otherwise, if you need to build for Android or for any other platform, you need to go to build settings and you need to change your build platforms from here. So as you can see, you can build it for PC, Mac, and Linux. You can make a universal Windows platform app for TV OS, for PS4, for Apple, Xbox, and even the web. So we'll be coming back to Android tomorrow, but for today, we'll just stick to the PC bits. Now, the first thing that I'm going to do is you must see this main camera and directional light in between. So we're going to delete this camera and just click on it, press delete, and that's it. The camera is gone. And now we will add an AR camera into the scene. So AR camera would be our device camera in the virtual scene that will help us see what the camera is seeing. So just go to game object here, go to Vuforia engine, and click on AR camera. As you can see, we now have an AR camera in our scene, and there is a bunch of settings here to change different things that the camera sees. Now just scroll down and you'll see open Vuforia engine configuration button. Click on it. Now, what we need to do here is we need to, number one, get a license for Vuforia, which is like a two-minute thing. You just need to sign up on their portal and get a license. And secondly, we need to add a database. Now, a database is, in Vuforia terms, is basically a collection of images that you use to augment whatever models you want to augment on your object. So just click on the add license button and this page will open up. Now, if you don't have a Vuforia account, which I don't think a lot of you do, just log in and make one really quickly. I will give you all 5 minutes for this. And then as soon as you have your accounts, you can let me know in the chat that it's okay to proceed. Is everyone following along with me? Okay, so now that you've made an account and you've logged in, you must be seeing these two things. So you must be seeing a license manager and a target manager. First, we need a license. So as you can see, I have like a bunch of licenses here that I use for different workshops and stuff. So just click on get development key. Wait for it to load. Type in a name for your license. I'm just going to type in the same name. these are the terms your license comes with. So you have cloud targets, view mark templates. You'll get only one view mark templates. This is not something we're going to be dealing with directly, or at least at this basic stage of app development, but it's good to know that you will be faced with these restrictions if you just use a free license. Anyway, just check this box here, type in a name and click confirm. And now you will see a license generated for you. Just click on it to proceed. Wait for it to load. And here is the license key that we need to copy into the Vuforia camera settings. So just click on the gray area, the gray box, to copy the link, copy the license key, and head back to Unity. And under the app license key, just copy paste it, and you're good to go. Now let's get back to making our database for the image. Click on Target Manager. Have you guys set up the camera? Okay. It's the same thing as having a license. You just click on Add Database and type in a database name. So I'm going to use the same name again. Okay, it doesn't have spaces, so okay. And now you will notice that there are types of databases that we can make. So it's a device, a cloud, and a view mark database. What this means is essentially a device database works locally. So this, whatever images and whatever augmentation points you save in this database will be saved on your device itself. It won't have to connect to the internet or find a backlink to get the device working. So this means that your app can work offline as well. If you want to implement cloud connectivity to your app, you can go ahead and pick the cloud database. Again, you'll need to specify which license key you're working with if you're doing that. And then there's a ViewMark database. So the ViewMark database works along with ViewMark, which is a 3D modeling application, and gives you a lot more control over how augmentations go. But for the sake of simplicity, we'll just go ahead with a device database. Click on create and just wait for a second. Okay, all right. Now that we have our database ready, we need to add targets to this database. So a target is exactly what it sounds like. A target is basically what your image or what your app sees to augment things on it. So you can use any image you like here. I am just going to use an image of stones to demonstrate something to you. So just click on the add target button. And now we have a bunch of things. So you can have a single image. If you're working with an image or with a plane, that's what you're going to be using. You can use a cuboid. So you can have like a concrete block in the real world and just enter its dimensions here. And then every time that block comes into the scene, your object will be sort of augmented on or around it. You have cylinders, that's what you can use, and then a 3D object. So Vuforia has an object scanner built in that can scan any real life object and turn it into a 3D object for you to reference with and in an app or inside of Unity. So if you want to object something, let's say around you, so you would need to have your own object scanner data for your body's dimensions, and you'll have to be putting it in here. Again, we're going with a single image, and now we have to choose a file. So you can choose any image. It just the maximum file size is 2 megabytes. So keep that in mind. I am going to use this image of stones. Why this image of stones? I'll tell you in a second, but I'll just enter the width as 5. So the width is basically the scale. If you remember from the presentation, we talked about having 2 different coordinate sets and being able to sort of merge them into one global coordinate set. Width here implies how wide the image has to be for the width of your 3D object to be affected. So that is where this point is where your two local coordinate systems merge into one. You can play around with this. I like using 5 because it gives me a good scale, but you can enter your own value and be just fine with it. And then you can, of course, change the name of your target if you're looking to do so. Click on add, it will upload your image. And here you have your target. Now you'll notice something called rating here. So if I click on it, and yeah, let it load, it has a 5-star augmentable rating. What this means is if I click on show features, you can see a lot of these yellow dots here. These are all augmentation points. So each yellow dot represents a point where you can augment an object. And of course, the more of these augmentation points, the better an image is suited to be augmenting things. So for example, this has a 5-star augmentable rating. So it's very easy for us to augment anything on this image. It will catch at most camera angles. You won't have to, fiddle around with the settings. You won't have to make sure that the angle is right or there is noise. So this is where we reduce our failure of registration when working on AR. If you have a good augmentable image to start with, you can reduce your failures down by quite a lot. And so now we just go back to our database and we're going to download it. And then we're going to import this database inside of Unity and then continue from there. So just click on this download database button here. And now from here, select Unity Editor. So of course, since Vuforia works with a bunch of applications and utilities, it works with Android Studio, Xcode or Visual Studio, it works with other editors as well, and it works with Unity. So since we're not working directly on code, we're going to use Unity. So click Unity in the checkbox and click on download. This will compile your database. If you have a lot of object targets, it will take a little bit longer to compile the database. If we just have one, so it gets compiled rather quickly. And now we're going to save it somewhere memorable. And yeah. Okay, how many of you have reached here? Let me know in the chat as you download your databases, and then we'll continue. I use the width can be anything. I like to go with 5. The width basically determines what is the scale of your augmented object to your real world object. So depending upon what image you're choosing, if it's a bigger image in terms of resolution, use a bigger width. And if it's a smaller resolution image, you can just use 4 or 5. Guys, let me know as you download your databases. I haven't seen any acknowledgements from anyone yet. Okay, guys, so let's continue. Now come back to Unity. You see this inspector panel, just scroll down. Here's the add database button. Click on it. Or if you want, if this button is not working for you, what you can do is just open the folder where you have saved your package and just double click it and it will automatically import. So this has our image that we're going to use, and then a data file and an XML file that determines the visual properties. Just click on import and we should be good to go. Just wait for a second for it to import it, and this should reflect here soon enough. Yeah. So as you can see, now my database has been imported. I see Aryabhatta AR workshop database name here. So now what we're going to do is we're going to import this image in Vuforia or in Unity rather, and start working with the 3D objects. So click on game object, head over to Vuforia engine. You'll see the image option. There are obviously multiple things. So if we have multiple images in our target, we use multi-image, cylindrical image for again cylindrical images. If we had used the cloud database, we would be using cloud image here, then model targets, camera images, a 3D scan if you want, and then view mark things. You can also work with ground planes if you want to augment things on the floor, but that's a little bit complicated, so we won't be getting into it today. So let's just move on with image, and as you can see, it has automatically imported the image I had. Here is the image texture, as you can see, and these are all the material properties, occlusion, collision direction, the things that I was talking about in the presentation. And we can modify all of these properties here depending upon how we want our image to be. But since this is just a 2D image, I'm just going to leave the properties at their defaults. Now you can change the scale or rotation and position of this image using the transform window here. So I'm just going to make it a little bit bigger. Let's just say I'm going to make it 10 so that my image is a little bit more visible. Can you all see the image here? Can I have some feedback? Okay, great. So now we're going to now there's, you can call the fun part that starts. So now we're going to import a 3D object that we're going to augment on this image. The good thing about Unity is that there is an asset store built in. So if you want to pull a 3D object or a 3D model, you don't really have to do anything. All you need to do is just go to window and click on asset store right here. And this will launch the Unity asset store inside of Unity itself. So you don't even have to leave the software. Just let it load. And here we can search for assets. So whatever you want to augment right now, just search for it. I will search for Cyber Soldier because this is my favorite model by far. I use it all the time in a lot of my projects, and I already have it downloaded. So it just makes me easier. You can use anything. There are paid models on it. Obviously, some of the models that are more detailed are paid, but there are a lot of free models. You can just use them. Just make sure whatever model you use should have an FBX file. So an FBX file is essentially a 3D coordinate file of the model's armature. Just like your body has a skeleton, a model has to have a skeleton so that it can interact with the world around it in a realistic sense. And that FBX file is what we're going to need to be able to augment our models on it. So I'm just going to this Cyber Soldier fin. You will see a download button here instead of an import button. So you're first going to have to download this. Once you've downloaded it, you'll see an import button. Let me know when you guys have finished downloading it and you're on the import stage. Okay, so have you all downloaded your models? It doesn't have to be this Cyber Soldier, it can be anything you want. Okay, all right. So just click on the import button. It will load the model a little bit, and then this asset folder will open. So now you can see there are different files here. This is the FBX file that I was talking about. This is what we're going to use. There is going to be a material file as well. So this will be all of the materials that are used in the model, and that is what we'll be using for occlusion. So just click, make sure all the files are selected, and just click on import and let Unity do its thing. Okay, now that we're done with the asset store, we can just go ahead and close it. And yep. Are you guys following? Let me know when you have imported the model. Okay, so now under the assets window, you'll see a folder called My Assets. And there'll be your asset, whatever model that you have imported from the Unity asset store. Just double click on it and you'll be able to see all the files. And this is a Cyber Soldier file. Now we're just going to drag this here. And as you can see, a model has been imported onto the scene. Now this is obviously very small, so we're going to increase the scale. I'm going to make it, let's try 5. Okay, no, 5 is a little bit too big, so let's try 2, 2, and 2. Yes, that looks okay. All right, so and now you can adjust the rotation. You can, so like I said during the presentation, that there are 3 axes to everything. Now the way you see your model in this view right now, this is exactly how your model is going to be presented when you show this image to the camera in real life. So for example, if I'm showing this at a 90-degree angle, my model will look like it's standing on the image. That's the whole slew of the situation. So if you want to change that, you can just go ahead and change the rotation. So if I want to rotate it on the X axis for 90 degrees, I can make it fall face down, or I can do minus 90 degrees to send it that way. I can just lift it up on the Y axis a little bit. And then as you all can see, let me just select the monitor, and yes, this is what we're seeing right now. So if you show the image to the camera in this perspective, this is how you will see your bot or your model or whatever it is that you've imported. Let me just reset these changes real quick. Okay. Okay, and another important thing I forgot to tell you, if you want to move around in the 3D space, just press the middle mouse button and you will get this hand icon, and then you can just drag the whole thing around, and using the right click, you can rotate your view around the axis that you're looking at. So using these 2 controls, you can move around, check if your model is where you want it to be. You can move it to the left, move it to the right. I can have it placed anywhere I want. And then you can just use numbers or just pull to your mouse cursor over X, Y, or Z, and then just click and drag to change their coordinates. I'll just set it centered. Let's just increase the size a little bit. I think let's just go with 5. No, not 45. Yes. Also, when you're scaling things in 3 dimensions, make sure that all the three scale objects are same, because otherwise you will end up with very weird proportions, as you will mess up the object geometry. So if I, let's say, set the height to 3, you will notice that while the object looks a little bit morph, because while the width and the sort of length is still 5 units, the height has been decreased to 3. So our object looks like a dwarf, which is not something we want. Or so make sure you have the same credentials across all the scale vectors. Are you guys with me? Okay, great. Any questions, any doubts up until this point? Okay, so let's continue. Before we go, so we are ready. Basically, that's all we need to do to have sort of a basic working AR app. You can just, all you need to do is now parent your image target to your cyber object. So now if you run this app right now using this play button on top, if you run this right now, you can show the image, but it won't augment objects on it. That is because your 3D model, your cyber soldier, is a different object in the scene as compared to the image target. You want them to be linked. So all you need to do is just click on the cyber soldier and drag it on top of the image target, so it looks like this. So now the image target is a parent object of the cyber soldier. Works just like you have studied in programming languages, as there are superclasses, subclasses, or objects that you use to refer to another class. This is the exact same concept. You're basically just dragging and dropping instead of having to code things. You guys with me so far? How many of you have reached this stage? Just give me a show of hands in the comments, and then we'll move on to testing. Okay, I see 2 or 3 hands. What about the rest? Guys, I'm gonna need a response. I see 2 hands so far. 3. Only 3 people have reached the stage. Guys, we're nearly done with our task for today. Our basic AR app is almost ready. All we need to do is testing. So if you have any doubt regarding any step or any stage in the process, just let me know right now. Otherwise, we'll just move on with testing and wrap today up. Okay, guys, fine. Then we'll just proceed with testing our app. So all we need to do is, it would be best if you could have a printout of this image yourself, because that's the best way to, that you'll have a physically tangible object on which you want to augment. But what I'm going to do is I'm just going to open this image up on my phone, and I'm going to use that to augment this object. This will also demonstrate you how noise or other factors like brightness and reflections and things like that can reflect the accuracy of your augmentations. So just whatever image you have, just transfer it over on your phone or somewhere else, and then we'll get started. Okay, so now just press this play button up here, and this will launch up your webcam, as you can see. So now, and there you go. Now notice how we had a lot of augmentation points on this thing. So our soldier is pretty well augmented, even if the camera angle is pretty narrow and it can barely see the camera itself, and there are a lot of reflections in and around it. But I can reach out and almost hide the image, but it's still there. So that's the advantage of choosing a good augmentable image. You always have something or some augmentation point that can, that the software can read and have it move around. As you can see, the tracking works perfectly fine. I can move it around rather quickly and it doesn't lose track of it, even when there is so much of noise and reflections in it. There's also one thing that you should notice, that your image grows along with the scale of the real visible image. So if I zoom this in, you can see my cyber soldier just increases in scale as the image goes along. I can tilt the image and it goes along with it. It basically tracks perfectly to whatever I want it to be. And that's what we're focusing on today. That was all for today. So tomorrow we will be working on primarily how to replace this simple object with an image or with another video or things like that. We will also be seeing how we can use multiple images as view targets, how you can work on another app, how you can work with different types of media and things like that. So for now, any doubts that you guys might have, someone of you had a license issue, whatever it is, you can go all out in detail, type it out in the chat, and I'll help you through it so that we can have a hurdle-free session tomorrow.
If anyone has any kind of doubt, you can just text it in the chat box. I repeat, if anyone has any kind of doubt, they can just text it in the chat box, or otherwise, we'll wrap up with this. Please, anyone, doubts? Also, also, if there is something you face, any doubt you face while practicing this at your home, you can just reach out at us on the group. We'll see to it. Okay. So if anyone has any immediate doubts, you can just text it here, or you can text it in the group if you get it sometime else. We'll wait for a few minutes for your doubts.
So yeah, I think we'll be sharing the recording of this class in a few days. And Mohit, you can just unmute yourself and tell me what your problem is in detail.
Hello, hello.
Yes, Mohit, you can go ahead with your doubt.
Sir, actually, I think I'm not getting the license from Unity. Whenever I am trying, it is showing invalid license.
Can you share your screen and show me what the issue is?
Yes. Sir, invalid license.
Yeah, that is because you're using the wrong file. Just click on manual activation real quick. Just say you've saved this file, save it again. Just replace it with the file name. You don't have to change the file name, just yeah, just save it like that and replace the file that's existing. Now click on this link. Yeah. Upload this file here, the file that you just saved. Scroll down, click I don't use Unity in Professional, click next. Yep. Download this file. Yeah, it's right there at the bottom. Just click on save. Click on next. Now use the file you just downloaded. Yes.
For the
Okay. Does anybody else has any doubts? Any questions? Any theoretical issues? Issues with Unity or with Euphoria with the asset store? Or their tests didn't run? Can I have any response, guys? Okay, so I guess you guys should play around with Unity today in the evening. Have fun, just look around the asset store, figure your stuff out, use different images, any other objects or assets that you want. And then if you have any doubts, you can just leave them on the group and we will get back to you.
Thank you, Yadullah, for such a wonderful session. Now, as Yadullah said, I'd like everyone to experiment some things on their personal PCs. And if you just get stuck around anywhere, please let us know and we'll get through it. And I guess that's it for today. So, again, a very big thanks to Yadullah and a very big thanks to all of you for being in the workshop. Also, I see there is Mona ma'am. Mona ma'am, would you like to say something?
Hi, I'm so sorry I could not join, just some personal urgent commitment. And I'm so glad. Thank you so much, Yadullah, for taking out time. And I'm glad, think all the participants would have gained a lot and would be working on this tool today, and then they'll continue tomorrow.
Thank you, ma'am. The pleasure is all mine.
Yeah, and Yadullah, this is going to continue year after year, so be prepared. As an alumni, also, you'll have to take some sessions. Either if you're in this line, then take workshops, otherwise, take sessions.
More than happy to do so, ma'am. More than happy to do so.
Yeah, yeah. So I'm going to tell Principal Sir this because we have to build a good alumni association. So I'm going to tell him that we will have a resource person for life.
It's my honor.
ठीक है चलो good luck to the participants and then tomorrow we will also have a feedback form so the students can get that ready as well. Yeah, have you taken the question answers?
Yes, ma'am, I have. It's
Okay,
still
fine.
open. We still have a few minutes left. So anybody who has any more questions can still shoot it.
Good luck, everyone.
If anyone has any doubts, they can ask for now. And if you don't have any doubts, you can start leaving the meeting.
वहाँ 4 o'clock ठीक टाइम पे स्टार्ट हो गया था.
Yes, ma'am.
Okay, fine. Sir joined on time.
Yes, ma'am.
Okay, good, good. तुम प्रत्युष पूरी शायद जगह नहीं, इसलिए मैंने डिटेल में सुबह तुमसे बात नहीं की.
Maybe that might be the reason, ma'am. Okay, so we see here a doubt. Ayush Pratap Singh, can you please unmute yourself and explain your doubt?
Ayush, I'm gonna need a little bit more information on that.
After pausing the app, all the game objects, they are present in the hierarchy, but they're not showing in the game view.
That's because the game view is supposed to stay empty. Just click on the scene tab right next to the game view. You'll see everything there.
Sorry, I was talking about scene. Scene is empty.
Yeah. Could you show me your screen real quick? I see there is don't destroy on load an object loaded in your hierarchy. Why is that? Where did you import it from?
I did not import it. When I played, when I pressed the play button, it imported automatically.
Okay, so that shouldn't really happen, but that is a feature in Unity. So it basically, what is your computer's configuration?
8 GB RAM, i5, and 2 GB graphics.
Okay, so that could be the reason for it. On a few unsupported hardware types, Unity does this. So to clear up your cache buffer, it automatically destroys objects after you're done testing. That could be the reason why this don't destroy on load object is loaded. But if you remove this, just click it and press delete on your keyboard.
Is not working.
Right click on it. Even the right click's not working.
I have right clicked.
Do you? I don't see a menu here. Do you see the delete option when you're right clicking on it?
It is not active.
Okay. So I am sending you a screenshot. This is how your hierarchy should look like. So you have a background plane under your AR camera. It should not be there. So delete that first. Or what I would suggest is have you received an email with a link with for the steps to install Unity? You must have yesterday.
Yes.
Yeah, so use that link and refer to the steps in that article. I have written it. And try to get to this step again from the beginning without having to add these extra objects.
Okay.
And then if you have any doubts, you can just drop them on the group.
Okay, thank you.
Okay, thank you. Any more doubts, guys? Yes, ma'am, you were saying?
Yeah, I was saying was that right now maybe today it's too early to gauge whether they'll need another session. So tomorrow, if you feel, just do a more interactive session in which you're asking them to do it side by side, and then you can give them feedback. and have a few to share screen like you are doing right now. So we'll get an idea whether they're actually learning or not, and whether we need to have an additional session. So check up with them tomorrow. Today is too early to do that.
Sure thing, ma'am.
Right?
Yes, ma'am. That's what I was trying today as well. But anyways, thank you everyone for joining, everyone who's still here.
Right.
So that's it for today's session. You can play around with Unity, drop your doubts on the groups, and we'll get back to them tomorrow. Okay. Have a good evening, everyone.